This video is an introduction to algebra. In this video, we are going to see how algebra can be used to simplify arithmetical calculations. So we are going to start with an example to see how we can find the sum of the first 6 natural numbers. 1 plus 2 plus 3 plus 4 plus 5 plus 6. This is equal to 21, as many of you would have come to the answer by now. I'm going to do this calculation in a different manner. I'm going to pair the numbers from each end, and I'm going to pair 1 with 6 and 5 with 2 and come up with an answer. Now this gives us 3 number pairs that make 7. So can I write it as 3 times 7 equals 21? Now we are going to do 2 more such numerical calculations in the similar manner. This is because when I'm trying to prove a point, I need ample examples. Mathematics is logic and not magic. Therefore, let's do the next example, which is sum of numbers from 1 to 10. And what do I see here? I get 5 number pairs that make 11. So I get 5 number pairs that make 11. So this is going to be 5. Sum of numbers 1 to 10 is going to be 5 times 11, which will be equal to 55. Now the next example is sum of numbers from 1 to 14. Now in this case, I get 7 number pairs that make 15. Therefore, sum of numbers from 1 to 14 is going to be 7 times 15, which equals 105. Now, I want you to focus on the emerging pattern, and our purpose in doing these examples is to come with one single expression that will help us find the sum of natural numbers in one single step. With that in view, I am going to redefine these number expressions that I have got. And when doing so, I want you to look for the pattern. Now I'm going to define 3 as 6 divided by 2 and the 7 as 6 plus 1. And since both of them are multiplied, I'm going to use parentheses because within parentheses the terms also are multiplied. Now let's see over here. This is going to be 10 times 2 multiplied by 10 plus 1. And this is going to be 14 times 2 multiplied by 14 plus 1. Right? Now, the distributive property allows us to further simplify this as 6 times 6 plus 1 over 2. This is 10 times 10 plus 1 over 2, and this would be 14 times 14 plus 1 over 2. Now I would like you to look at each of the number expressions, observe it carefully, and we can see that there were some numbers that changed, whereas some numbers that did not change. So we see that in the first expression we had a 6, in the next one we had a 10, and In this one, it was a 14. Now, numbers that change in algebra, they are called variables. Variables are numbers represented by alphabets in small case, and these variables can take in any value. And as you see, they have taken on 6, 10. It can be 6, 10 and 14 in this case. Okay. Now we have also some other numbers that did not change. The 1, and the 1 remained the same. The 2, and the 2 remained the same. Now these are called constants. Now when we are making an algebraic expression, we make use of variables and constant. Now in this case, if I were to use a variable x in the place of the numbers that changed, then I would get an expression which would read as x times x plus 1 over 2. Now this expression is one comprehensive expression which gives me the sum of consecutive natural numbers from 1 to x. Now I have to also define that the x is any natural number, also that x has to be greater than 1, because we are trying to find out the sum of consecutive natural numbers from 1 to x. Now let's see if we can plug in a value for x and see what answer we get. Now let x be equal to 23. Let me just make a little space here so I can do my problem. So if x were to be 23, so let x be equal to 23. Then my expression would read 23 times 23 plus 1 over 2, which can be further simplified. I work within the brackets first, multiplied by 24 divided by 2. Now you know this simplification. 2 goes into 2 once and 2 goes into 24 12 times. So I come with an expression which will be 276 will be the sum of consecutive natural numbers from 1 to 23. We now know that through algebra, we can express ideas about numbers concisely. Now, algebraic expressions are formed using variables and constants. Variables are represented by letters in the small case a, b, c, d, x, y, etc. And the value of variables change. Now, in this video, we are going to write some algebraic expressions. You're going to write the algebraic expression with the help of the verbal cues that I provide you with. Now, first one that we are going to represent is an even number. How do I write an expression for an even number? Now, the verbal cue I'm going to provide you over here is that the even numbers are multiples of 2. They are multiples of 2. Now, the second one you're going to write is an expression for an odd number. And here I'm going to give you that odd number, since you all know that it either precedes or follows an even number. I'm going to say it is an even number increased by 1. Even number increased by 1. Then we are going to find an expression to represent the perimeter of a square. And here I'm going to draw a small square and state that a square has 4 equal sides, as you are all aware. The last one that we're going to do is the perimeter of a rectangle. Now, a square is also a rectangle, but all rectangles are not square. Perimeter of a rectangle. Now, a rectangle, as we know, has opposite sides of equal length. So I'm going to call this N, and this Y, and this Y. That's right. Now let's think for a while and then come up with all these expressions. That's right. Let's make some space for us to write the expressions. Here we go. And the first one, since you're all aware of factors in multiple, it is even number, multiple of 2. Therefore, I'll call an even number 2 times x. Now in algebra, by convention, when a constant and a variable is multiplied, or 2 variables are multiplied, we generally drop the multiplication sign and we just write 2x. And of course, x has to belong to the family of natural numbers or set of natural numbers. And here I'm using the N denotes natural numbers, and the Greek letter epsilon denotes belongs to. Now I would also like at this point to introduce another term, algebraic term, and here the 2 over here before the x is referred to as a coefficient. It's a coefficient factor. The 2 is a coefficient factor, coefficient of x. Now the second one becomes very simple because I have already defined an even number. So odd number is going to be 2x plus 1 because it says even number increased by 1. Let's plug in a value to see whether this works. And I'm going to plug x to be 5. 2 times 5 plus 1. What do I get? 11. Is 11 an odd number? Yes, it is. Okay. Now let's see what is a perimeter of a square. What do you mean by the perimeter? When I'm talking about perimeter, it refers to the boundary. And so if I were at this point in the square and I wanted to go round, that would be the perimeter of the square. So how much length would I have walked? So here we go. This will be 3 would be, I would have walked a length of s plus s plus s plus s. Here I want to bring to your notice that when a variable exists by itself, it has a coefficient factor of 1. That is, s is actually 1s. We drop or we omit the s, we omit the 1 when we are writing. So if 1 is the coefficient, it is generally omitted by convention. So this is going to be an answer 4S. Now let's see about the fourth one. Now the fourth one, we see that I have two lengths which are n and two lengths which are y. So if I'm going to walk around the rectangle, I'm going to walk one n, then I'm going to walk another y, then another n, and then a y. So I would have walked n plus y plus n plus y, which case I would have walked 2n plus 2y. Now here is another term in algebra that I would like to bring to your attention, and that is like term. And as the name suggests, the n and the n are like terms and y are like terms. So I can add or subtract two like terms together. So this can further, using the distributive, be written as 2n plus y. So here are some expressions that we did.